Hello friends, this question is from test series number 10. Subject name is network and topic name is RLC circuit. It's a linked data question. In a problem, we have one RLC circuit in which there is a one parallel part of the circuit which contains a 20 ohm resistor, 200 microfarad inductor and one parallel capacitor. Along with this network, we have one series resistor of value 8 kilo ohm. And this entire network is basically energized by the voltage source of 200 volt and the frequency of 10 raised to power 6 hertz or 1 megahertz. And the question says that in the first problem, question says that find out the value of C under the resonance condition. Question says that simply if this tuned network is basically is in the resonance, then find out the capacitor C. In the second circuit, we need to find the supply current IT. Okay, so first see the first part in which we need to find out the value of capacitor C. It's a very simple question basically because we know that in a tuned circuit the expression for frequency is omega RLC parallel circuit. The expression for frequency is omega naught is equal to the under root of 1 by LC minus R square upon L square. This is the expression of frequency, and in this expression we know the value of omega naught which is given to us, which is 2 pi under root of 10 raised to power 6, which is supply frequency because circuit is working under resonance. So we will assume that supply frequency is our resonance frequency, and in the circuit we know the value of inductor which is 200 which is 200 microhenry. So 200 into 10 raised to power minus 6 into C minus R. So we already know the value of R which is 20 ohm because we are right now we are just talking about this tuned network. So value of R is 20 ohm. So it will be 20 square upon L square, which is again 200 microhenry. 200 into 10 raised to power minus 6. So you can see that it's a simple calculation. We already know the value of R, L and omega naught. So in this expression only unknown is the capacitor C. So we can easily calculate its value. So by calculation the value of C is comes out as 126.6 microfarad. So value of capacitor is 126.6 microfarad. So for the first part the correct option is option B. B part is the correct option for first part. In the second part, question says that find out the current I, which is our supply current. That's what we need to find out. Let's name this as a IT. So we know that by Ohm's law, current is nothing but supply voltage upon equivalent resistance. So basically, first of all, we need to find out the equivalent resistance of the network. So Z equivalent will be equal to the 8K plus for the tuned network the equivalent impedance is L by CR. It's a standard reserve for any tank circuit. For any tank circuit the equivalent impedance is L by CR. It is RLC's tank circuit, so its equivalent network is L by CR. So there is no need of any further calculation. So you can just put the value of L, C and R, where L is 200 microhenry, 200 into 10 raised to power minus 6. C is nothing but 126, which we have just calculated, 126 into 6 into 10 raised to power minus 6, and R is 20 ohm, sorry, 20. So our my Z equivalent will be equal to the 87K approximately. You can calculate the Z equivalent, which is 87K. So we know the Z equivalent, we know the supply frequency 200 volt, so we can easily calculate the current I. My IT will be equal to the 200 by 87K, which is 2.298 milliampere, right? Which is approximately equal to the 2.3 milliampere. So for the second question, my correct option is option C. For the first question, option B is the correct option. For the second question, option C is the correct option. That's all. Thank you.